Okay, let's go over the worksheet. So the first thing we want to do is find the sum of the measures of a 14-sided figure. So that formula is n minus 2 times 180. That gives you your total value of all the interior angles, no matter how many sides you have. So 14 is your n. So 14 minus 2 is 12. And 12 times 180 gives you 2,160. Now, number 2, it works it backwards. It tells you the total. So you have n minus 2 times 180 equals the 3,240. Everybody see that okay? So how do we solve for n? The first thing you need to do, you could distribute the 180 and then solve it if you wanted to, or you could just divide off the 180. And then you'd be left with n minus 2 equals 3,240 divided by 180 is 18. And then if you add 2 to that, you get 20. So it was a 20-sided figure. That's how that works, okay? All polynomials have exterior angles that add up to what? So number 3 has everything to do with number 6. Those are all exterior angles. So all of these add up to 360. So number 3, no matter how many sides you have, all sided figures, all polynomials, the exterior angles add up to 360. All right? All right, so now find x. So this is a 1, 2, 3, 4-sided figure. So 4 minus 2 times 180 is 360. 4 minus 2 is 2. 2 times 180 is 360 degrees. So x plus 29 plus 88 plus 154, all of those add up to 360 degrees. So we take 360 minus 154 minus 88 minus 29. So we're subtracting these to the other side. And that leaves x on the left and 89 on the right. So, okay. Then on number 5, how many sides do we have? 1, 2, 3, 4, 5, 6 sides. So 6 minus 2 times 180. 4 times 180 is 720. So again, add all those together. So I see 90 plus 99 plus 171 plus x plus 159. That equals 720. And you just do it again. 720 minus each of these. So you're going to move all the numbers to the right side, okay? So 720 minus 159 minus 171 minus 99 minus 90. That equals 201. What's on the left? We still have x plus x, which is 2x. So we divide by 2 and we get 100.5. That's what each x is. And tomorrow it may ask you for what, for you to plug the numbers back in and get a value of something. Just be ready for that. If it just says find x, just find x. Okay, number 6. These are exterior angles. Okay, I don't have to count the sides. They add up to 360. So 2x plus 71 plus 85 plus 44 plus 3x equals 360. No matter how many sides. Has everybody got that? Okay, so now you just subtract all the numbers to the right. So 360 minus the 44 minus the 85 minus the 71 is 160. So what do we have left? On the left side, we have 5x. 2x and 3x is 5x. So now we divide by 5. 160 divided by 5 is 32. All right, second sheet here. find x. It doesn't say find y. It's just in the picture, okay? So in a parallelogram, opposite angles are equal. So x minus 21 should be equal to 105 degrees. So just take 105 and add 21 to it, and you get 126. So plus 21 plus 21, x equals 126. So show all your work, okay? Now find AB. AB is not an angle, remember? Remember, 2 letters is a length of a side. As opposed to number 9, BCA. BCA has 3 letters. So that's talking about an angle. It actually says angle. So AB. AB is the total length from corner to corner. And in a parallelogram, diagonals bisect each other. So those two, AF and FB, are the same. So 6 and 6, that is 12. BCA. So here we're talking about that little angle. So we have parallel lines cut by this transversal. So those are alternate interior angles. So x is 40. Okay. Number 10. Again, we're just finding x. So I can't set these two equal to each other because that has a y and that has an x in it, okay? But these two are equal. And they both have x's. Those are your angles. Parallelogram. Opposite angles are equal. So 4x plus 13 is equal to 5x minus 12. So I'm going to subtract 4x so that I have a positive x on the right. And I'll add 12 to the left. So x is 25. Number 11. It's a parallelogram. So the diagonals bisect each other. So these two have to be equal to each other. So 6x must be equal to 3x plus 2. Subtract 3x. 3x equals 2, and divide off the 3. 2/3 is the answer. If I wanted the length of the diagonal, you have to substitute that back in. All right. Now, 12 through 17. So let's blow this up a little bit here. All right. So it says it's a rhombus. Okay? Rhombus. That means that this is 90 degrees. Diagonals are perpendicular to each other, and there are angle bisectors. That means this angle is equal to that angle. This angle is equal to that angle. These two angles are equal to each other. They're angle bisectors, only in a rhombus and a square. So, if this is 13 in the middle, 90, then 13 is 90 degrees. And since these are angle bisectors, number 17 is 30 degrees. And a rhombus is a parallelogram, so opposite angles are the same. So if this corner is 60, then the upper left corner is 60 degrees and is bisected equally to 30 and 30. Now, how do we get 15 and 16? 2 different ways. So in a parallelogram, it's 4-sided figure. They all add up to 360 degrees, the inside angles. So we have 60 and 60, that's 120. You could take the total inside angles, 360 degrees, subtract each of those, 120. You have 240 degrees left to be split evenly to those 2 corners. So that means 120 degrees each. And then the diagonal bisects each of those evenly. So each of these are 60. And the same thing over here. The other way to do it is this. This bottom triangle right here, there's 180 degrees in a triangle. The top corner is 90 degrees. You have 90, and you have this 30 degree angle here. That's 120. What does that leave? It leaves 60 degrees left for number 15. Okay? Who got all of these on the second page right? Okay. All right. Who only missed 2? Okay. All right, last page. Find angle SRT. So we're looking for that angle there. It is a rectangle, which means these are 4 right angles. X is not 34 degrees. If this was a rhombus, then yes, you could say that's 34 degrees. Or a square. But those 2 angles are definitely not the same. But at angle T here, QTS, it's 90 degrees. So we ought to get QTP. 90 minus 34 is 56 degrees. Okay? You have a rectangle, which is a parallelogram. It's cut by a transversal. So 56 degrees should be equal to the X, alternate interior angles. So the answer should be 56 degrees. The other way to do that, there's another way. Is that you have this right triangle here. Can you even see that? It's hard to see on that. It's blue on the screen. 180 degrees in a triangle. Well, you have 90 there and 34 there. 90 and 34 is 124. If there's 180 degrees in a triangle, 180 minus 124 gives you 56 degrees. There's different ways of finding your angles, okay? All right. It's a square, which means it's also a rhombus. All rules apply. That's 90 degrees. All of those are the same. Let me use black so you can see it. All 4 sides are the same. Opposite angles are the same. Angle bisectors, blah, 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 blah. It's asking 2 letters, which means length. M to P. Well, all the diagonals are cut evenly, and they're all the same, all the segments. So 4 and 4. So this is 8. Pretty simple. Next one. Same one, LN. It's a square again, so those are the same. So 4 and 4, that answer is 8. Those were pretty easy. Now, is a square. A square. You're starting with a square. It's important to know what you're starting with. Is a square always, sometimes, or never a rhombus? So what you do is you have to know the definition of the second thing. The definition of a rhombus is that it has 4 congruent sides. It has all that other stuff that goes with a parallelogram, but the definition is there are 4 congruent sides. So then you go back to the first thing and you say, does the first thing have that always, sometimes, or never? So does a square always, sometimes, or never have 4 congruent sides? Always. So that means a square is always the rhombus. So you think about the definition of the second thing and ask the question about the first thing. Definition of a rhombus. All 4 sides are the same. Does a square always, sometimes, or never have that definition? And yes, it does. Always. All right. Now, who got all of those right? All 21 questions. Anybody? Awesome. Okay, let's do some more questions. Given a parallelogram, obviously that is not a rhombus. It's longer than it is tall, okay? So let me put a few things on here. Diagonals. And let's say this is 50 degrees. And this whole corner here, we'll say that is 110 degrees. We'll say this side is 4. Let's see here. A, B, C, and D, and E. We'll say AE is 5. We'll say DE is 8. And another angle, we'll say this is 40 degrees here. All right, so now you're going to answer some questions for me. What is AD? Go ahead and answer it, and then I'll answer. I forgot something. Let's put 12 right here. AD is the same as BC, so that's 12. It's parallelogram, so opposite sides are the same. Okay. What about BA? Write that down. I'll just write a whole bunch of these down here. You answer them. All right, so 6 things there. Okay, so BA is 4 because opposite sides are the same. And BE is 8 because in a parallelogram, diagonals bisect each other. Now angle BAD. All right, so BAD, this angle right here, the big angle. It's 50 plus whatever this is at the top. But BAD in a parallelogram, opposite angles are the same. So BAD must be 110 degrees. EAB. So EAB is already there. That's 50 degrees. I think they meant to say, what is angle EAD? What's EAD? It's 60. How do you know that?
Because the other one is 110, so we just minus that from 50.
Yeah. The whole thing's 110, so this must be 60. And if I asked you, you could give me this angle right here, because there's 180 degrees in a triangle, right? You could figure that out. ABD, angle ABD. So they're asking for the angle right there. ABD. What do you think that is? Pretty hard to figure out, but because we have that triangle at the top, 60, 60, and 40 is 100, that means this angle is 80 right here. Doesn't look like 80. But that means this is 100 at that position because it's a supplementary angle, isn't it? And so now you have a triangle with 2 angles, 150 degrees. That leaves 30 degrees left. And I think on the test it's probably going to put the X here or whatever. May not be an X, maybe just asking what it is. And this would be an alternate interior angle with that one up there. So alternate interior angles is used a lot when we're figuring out angles, okay? All right, but either way, my point is to show you that you should be able to figure out as many angles as possible, if not all of them. You have vertical angles here where the E is, that's 80, that's vertical. 100 degrees over there. You should be able to figure out just about everything. All right. Okay. We'll do some easy stuff again, but let's go ahead and show you some other things that are going to be on the test. You have to name the theorem based on what I give you. okay? They give you some theorems to choose from, so, but guys, you should know what the theorems are. Angles, opposite angles theorem, opposite sides theorem, okay? So let me put something on here. Oops. Let's see here. I'm not asking for the shape, I'm asking for the theorem. So you have definition, both pairs of opposite sides are parallel. Parallelogram, let me just write them down here. The definition of a parallelogram, opposite sides are parallel. So that's the definition of a parallelogram. Number 2, parallelogram, opposite sides converse. Number 3, parallelogram, opposite angles converse. Converse means that you're proving that it is a parallelogram, okay? Basically, if there's no parallel markings on it, then you should be using converse in your answer, okay? Number 4 is opposite sides parallel and congruent theorem. And number 5, parallelogram diagonals converse. Okay, so based on what those 5 are, which one best describes that picture? So here's how you go about doing this. Number 1, are there any parallel markings? So that means definition of opposite sides are parallel. No, there are no parallel signs. Opposite sides are parallel and congruent. Well, you don't have any parallel sides to say that you have opposite sides are parallel. So those 2 are gone, all right? So that leaves 2, 3, or 5. So let's just go down the list. Number 2, opposite, in the parallelogram, opposite sides are congruent, all right? That's what that says. Parallelogram, opposite sides, converse. Converse means there's no parallel markings. So do you have opposite sides being congruent? Yes. Okay, that could be it. Number 3, opposite angles. Do you have opposite angles being congruent? Yes. Do you have the diagonals? There are no diagonals in there. So 2 or 3 could work for this one. Okay, there's only going to be one answer for each of these. All right, so 2 or 3 could work for both of these. All right, let me give you another picture. Okay, so give you a second to think about it. It is number 5. The diagonals bisect each other. That's what the parallelogram diagonals converse theorem states. If your diagonals are bisecting each other, then it's a parallelogram. All right, let's erase that and do another one. Pretty simple so far. Give you a second to think about that one. Number 1, definition of opposite sides are parallel. Good job. Pretty simple? Yes? Easy? No? All right, let's do another one. Number 3, parallelogram, opposite angles, converse. If your opposite angles are congruent, then you have a parallelogram. Okay, let's go on from there. Let me just draw a picture. So we'll do this. A, B, C, D, E. And we'll say this is 30 degrees here. This is 11.7. This is 4.1. Using decimals because depending on which version of the test you have, there will be decimals in your answers. Okay, let's just change it up a little bit and say that this angle right here is 110 degrees. We'll just do that, 110 degrees. All right, answer these questions. All right, so let's find AB. Well, in a parallelogram, AB is the same as CD, so that's 11.7. And BD is the full length of this diagonal. In a parallelogram, the diagonals bisect each other, so therefore these two are the same. So this is 4.1. That makes BD 8.2. Now, the measure of angle BAC, this angle right here. So it is an alternate interior angle with that 30 degrees. So it should be 30 degrees. And then BDC, all right? So there's a way to figure some of this stuff out, but you couldn't have figured out BDA or BDC or these two, either of these two, if I didn't give you one of them, okay? Or a way to use triangles and stuff. So the 47 degrees there helps. It makes the top right one 47 degrees, okay? If this is 110 degrees, then angle D, the big angle there, is 110 degrees. So 110 minus 47. Okay, so 110 minus 47, that's going to give you 63 for angle BDC. The other thing you could do is you could find any of these other angles. If I take this angle out right here, this triangle, this is 110 and this is 30. You could tell me this other angle at the bottom because there's 180 degrees in a triangle. That's what you need to be thinking of all the time. You also need to understand what they all add up to. 360 degrees in a quadrilateral. There's different ways of figuring out these things, okay? So make sure you can do those types of things. Use those tips I've just given you to help you. So rectangle, A, B, C, D. Okay. So now you need to know everything about a rectangle. And if I say that CD is 21 and BD is, let's make it 50, and the measure of angle CAB, let's make that 75 degrees. Okay, now answer these questions. What is AD? What is BA? What is AC? And what is the measure of angle CAD? Okay, so it is a rectangle, and make sure you pay attention when you're reading these things what type of picture it is. Okay, so AD is the same as BC, but we don't have all of that yet. Hold on a second. Oh, I'm sorry. So BD should be, I forgot this part. This should be ED, the first one, ED. So, yeah, if that stumped you, sorry. What is ED? So ED is the same as BE, right? But BD, the whole thing is 50, so each of those must be 25. So I apologize, sorry. So BA is the same as CD in a rectangle, so that's 21. And AC is the other diagonal And in a rectangle, both diagonals are the same, so this is 50. And then the measure of CAD. So this angle right here. How do we know what that is? CAB is 75. So yeah, on some of these pictures, you should write in what they tell you. All right? So how do you know what X is?
Would you subtract 70 from 90?
Yeah, so in a rectangle, all of these are 90 degrees. So 75 away from 90 is 15 degrees. So it's a very skinny rectangle, okay, or flat rectangle. Okay. So, quadrilateral, parallelogram, rhombus, or square. What is the best name for the picture? So here's the picture. So a rhombus, all four sides are the same. All four of these sides are not the same. In a square, all four sides are the same. This is definitely not a rhombus or a square. The best name for this would be a parallelogram. Because in a parallelogram, you have opposite sides being congruent to each other. Okay, so parallelogram is the best one for that. Let's add something here. Let me actually just draw another one. What if I said this? If I just did that, what would be the best description? Give everybody a second. Okay, what do you think?
Quadrilateral.
It is, all of these are quadrilaterals. So let's start there again. Parallelogram means opposite sides are parallel. We don't have that yet. And also the opposite sides are congruent. We don't know that. Rhombus, definition of a rhombus is you have all four sides the same. We don't know that. In a square, all four sides are the same, and all four angles are the same. So based on that part, in this picture, the best thing would be it's a square, okay? If I put rectangle up here, which one would it be, a rectangle or a square? The definition of a rectangle is that you have four right angles. Because you don't have all the four sides marked, you wouldn't say square. Now, if rectangle wasn't on there, square is the only option. Okay? So rectangle would be the answer for this one. I'm just trying to make you think. So let's draw another one. Okay? It's a quadrilateral. Okay, it is not a parallelogram. And all of these are parallelograms except for the word quadrilateral. Okay, a quadrilateral can be a parallelogram, but it's also all the other ones. Any shape, any four-sided figure is a quadrilateral. Okay, so let's do another one. You're going to be asked this stuff on the test, so hopefully you're catching on here. Let's do this one. And everybody said? Square? Okay. It's not always difficult. Rhombus. Yeah, all four. Definition of rhombus, all four sides. Okay, good. All right, good. Let's stop with that one. Here we go. I want to know what each angle is in a six-sided regular polygon. So, yeah, this is weird. It was asked in your homework so you may have forgotten about this. First of all, you have six-sided figures. So 6 minus 2 times 180 gives us the total of all the interior angles. So 4 times 180 is 720. So you have a six-sided figure. Wow. So what is each of these angles? It says regular, which means all the angles are the same.
Just 120.
So don't you just divide it by 6 to get what each one is?
Yeah.
Which is
120.
120. That's the answer. All right, let's try that again. What is each interior angle on a
Are we gonna have
14-sided polygon? What's your question? So you have 14 minus 2 times 180. So 12 times 180 gives us 2,160 for all of the angles added together. What is each one? You have to divide by 14. Be careful, don't divide by 12.
154.285.
Yep, 154.3 degrees. Okay. All right, so be ready for stuff like that. I mean, you're expected to know decimals and fractions and stuff, but I'm showing you everything, getting you ready, so you should be all right. Just be ready for that stuff. Okay, what else? You have a 22-sided figure. What is the total measure of the angles? So 22 minus 2 times 180 gives us the total measure of all the angles inside. So 20 times 180 is 3,600. Okay, good. Well, if I told you, let me see here. You have 2,700 degrees on the inside. That's your total. How many sides does that figure have? So n minus 2 times 180 should equal 2,700. So we divide off the 180. So n minus 2 is going to equal 15. And you add 2, so you must have a 17-sided figure. All right, y'all feel pretty confident? Awesome. I would like to know each interior angle of a 7-sided figure. Regular figure. Regular means they're all the same. All right, so here's how you do this. First of all, we want interior angles. So 7 minus 2 times 180 is going to give me what they all add up to. So 5 times 180 is going to give me 900. Well, how many angles are there? 7, and they're all the same, right? So if I just divide that by 7, won't that give me each one? 128.6 degrees. And yes, you will have decimals depending on which version of the test you get tomorrow. Okay? All right. Let's try it again. So each interior angle, please, for a 12-sided regular polygon. We got 150. All right, good. So you got 12 minus 2 times 180. You have to figure out what the total is first. That's 1,800. And then you divide by how many sides you have. Be careful not to divide by 10. Don't do that. So you divide by how many you have, and that gives you 150 degrees for each interior angle. Okay. Let's do this problem. Find the value of x, please. Okay, so you have exterior angles. No matter how many sides you have, they add up to 360. That's the total. So I have 60 plus x plus 70 plus 58 plus 79 plus 2x. All those together should be 360. So I subtract all those. So 360 minus all of those is going to be 93. And we're left with an x and a 2x on the left side. So that's 3x. And if you divide by 3, x is 31. So here we have, let's do this picture, and we'll do that. And we'll do x, and 110, and 102. All right, find the value of x, please. Okay, so there are 5 sides. So all the interior angles add up to something. So 5 minus 2 times 180, that's going to give you 540 degrees. 3 times 180 is 540. So you take 90 plus x plus 110 plus x plus 102 and set it equal to 540. So you subtract all those from 540 and you get 238. On the left side, you still have your x's. So we subtracted all these numbers. X and x is 2x. Then you divide by 2. So x is 119. The first thing I want to do, just for practice, is show you that you can figure out so much in this figure. Okay? So, I'm going to move these down for a second. Blow this up a little bit more. And just start writing on this. Okay, so we know this is, what I say, 85 degrees. So this whole thing is 85. And this is 40 degrees. So without even answering the questions, let's just start writing some things in. I'll do this in red. So if this is 40 degrees in a parallelogram, alternate interior angles show me that that's 40 degrees at the bottom right. And if that whole thing is 85 degrees, that means the other angle is 45. And again, with alternate interior angles, the upper left should be 45 degrees in that position. Alternate interior angles. I see it's a parallelogram, so diagonals bisect each other. So AE should be the same thing as EC, 8.7. And vice versa on BD. 5.1 should be the same as BE. And then BC, 12.5, should be the same as AD. And DC is 9.3, so that's the same as AB, 9.3. Now the tricky stuff comes in with the degrees. We need to understand that the 85 degrees is supplementary with angle B and angle D, the big angles. So if the bottom right, the whole angle is 85 degrees, then that means ABC must be what? What's supplementary mean? 180. So that whole angle is 180 minus 85, or 95 degrees, right? Obviously, it's not drawn properly. And opposite angles are the same. So the big angle D is 95 degrees. And we see that part of that is 43 degrees. So what's left? So 95 minus 43, is 52. And again, apply alternate interior angles. So this is 43, and that's 52. And guess what? You can give me all the angles at point E, because you have 4 triangles there, and in each triangle, they add up to 180 degrees, don't they? All right, so let's do the left triangle, ABE. You have 45 degrees and 52 degrees. That's 97. So 180 minus the 97 will give me this right here. 180 minus 97. That's 83. 83 degrees. And you know vertical angles. So the angle on the right would be 83 degrees. And you know this is a straight line, which makes 180 degrees. They're supplementary. They're a linear pair. So 180 minus 83 is 97. And where E is at, that's a vertical angle to that position. So that's 97. Do you see that you can go through and answer just about everything if they give you the right positions? Okay, having said that, that's important to actually look at. And now these are separate from each other. Okay, so we've answered all these questions. AD is 12.5. BE is 5.1. ABD is 52 degrees. BA is 9.3. BAD is 85. And EAB is 45. Obviously, we answered more than what's on there, but that's just to help you prepare for tomorrow. You don't know which ones I'm going to ask you. Okay? And maybe they don't give you enough information to answer all of them. We filled out the whole thing. Just remember that every answer is possible. It's not impossible to figure it out. All right. I'll put a picture on here, and then you tell me which theorem is best describing it. Okay? So think for a second. So if you said number 1, do you have any parallel markings? No. So we're looking for a converse theorem then. So number 2, it says parallelogram opposite sides. Do we have the opposite sides being congruent? Okay, so it's number 2. All right, let's erase that and I'll do another one. So how about this one? So 80, 100, 180. All right, take a second. Think. Number 3, opposite angles converse theorem. Okay. Easy, isn't it? Okay. All right, so think about what the answer is. What is the answer? Number 1, you have parallel sides, or they're marked with the parallel sides. Okay, so that's number 1. Definition of parallelogram. All right, let's do last one, then we'll change it up. Which one is it? Number 5. Number 5. Yeah, your diagonals bisect each other. Okay, good. Let me draw another picture here, and you fill it out, kind of like the other one here. Okay, so in the instructions, they call this a rectangle. Please read the instructions for the figure they're claiming it to be. Okay, so you know what a rectangle is. It's not trying to trick you. Now, answer these questions. What is CE? What is AD? What is BD? And what is the measure of angle BDC? Okay, first of all, let's just write everything in that they tell us. AC is 42, so the whole length of this is 42, or the downward diagonal. So each of these are 21. I'm just putting that in there just so I can write the 42. BC is 21. Okay. The measure of BDA is 50 degrees. Also, what do you know about a rectangle? All of them are 90 degrees. Anything else? Your diagonals bisect each other, and in a rectangle, they are the same. Okay, so now CE, 21. AD, opposite sides are congruent, 21. BD, downward diagonal and the upward diagonal are the exact same, so that's 42. And angle BDC If that's 90 degrees, then x must be 40. Who got all 4 of those correct? Okay. Give me the best description. Is it a quadrilateral? Is it a parallelogram? Is it a rhombus? Is it a square? Or is it a rectangle? The best description. Obviously, if I drew a square up here, you wouldn't call it a quadrilateral, right? All right. So let's draw a few things up here. Okay, so let's go through this real quickly. Quadrilateral, you just have to have 4 sides. Yep, it's definitely a quadrilateral. A parallelogram. Definition of parallelogram, opposite sides are parallel. Okay, we don't have that. We could prove it, but we don't have it on there. A rhombus. Definition of a rhombus, all 4 sides are congruent. That's not what's on there. So it's not a rhombus, and therefore it's not a square. A square has 4 right angles and 4 congruent sides. A rectangle has 4 right angles. You don't have 4 right angles. Even if it was drawn like this, guys, do not assume that you have 4 right angles if it's not on it. Okay? So the best description of this is what? Parallelogram. Okay? Because even though you don't have the markings in a parallelogram, opposite sides are congruent, right? Okay. So here's what I'm saying about the answer for a quadrilateral. Oh, let's do it that way. That's a quadrilateral. That would be the best description for that figure at the bottom. Right? Okay. So let's do another one. Let's do... Think about it. Rhombus, parallelogram. It's definitely a quadrilateral. Parallelogram, you could say it's a parallelogram as well. Out of those two, you would use parallelogram, but let's go on. A rhombus has 4 congruent sides. Okay? Always has 4 congruent sides. So that's even better than a parallelogram. What about a square? A square has to have 90 degrees, and so does a rectangle. So a rhombus would be the best description for this one. And yes, these are on the test. Okay. When would you actually say this one? What would you say for that one? What's the best description based on what I've put up on the screen? You'd have to say rectangle. You'd like to say square, but you don't have the information. But if I actually put this on here, then you would say square. Okay, good.